Bueno, pues buenos días a todos. Para nosotros es un placer.
Good morning to you all. It is a pleasure to be here one more year. It is a conference that we very much enjoy as speakers and as attendees. Well, Roman has already introduced me. So for you, well, to know, well, my name is David Perez and he is José Picó. And this time we are here to share with you something slightly different to what we have shared with you. In the past, we talked about mobile network security, but this is not the only thing that we do. In this case, this time, we are here to tell you about a number of tools that we needed to develop for a number of intrusion tests that we've been carrying out recently. So we are here to share these tools with you. So we tell you why we did it, we show you how they work, and if you find them helpful, well, please feel free to use them. They are available in our website as of today. Well, we'll give you the website address in the laptop. They are all there available to you. You may download them and play around with them. So, why was this Wi-Fi test special? Meaning that, well, we had to develop tools. The thing is that for some tasks that we had to do, well, what we had was not sufficient, was not enough. So this time, what really made the difference was this was an attack test to a Wi-Fi infrastructure. However, the premise was that we didn't know whatsoever the people who were attacked. That meant that the person who hired us were not the same people that were defending the infrastructure. So we didn't have any access to the building. So we didn't go there. We couldn't go there to deploy the tool, to walk around the building. Not at all. The main requirement was that no one should know that we were doing that, and that was a great conditioning. So as I say, this is the address name. This is the address where you can download all the tools. Well, the first tool that we developed, we gave name a weekly tattoo, which stands for Wi-Fi, client, and tattoo. So it is a tool that helps us attack the client devices. It doesn't launch any attacks, but it helps us launch attacks. So this tool is very simple. So in many cases, we wanted to be in a place and we wanted to see what were the Wi-Fi clients around us. So there are tools for that, but they were not very convenient for us. So we just developed this tool, and then it monitored all the requests of the clients around us. And then we wanted to see that on the screen and then to see it very clearly. The user's interface, we did that because we needed everything to be on a terminal, just to have remote access to it without, well, taking into account the bandwidth, etc. And then what is interesting about this is that you can choose the clients that are of interest to you. Well, you don't really want to see thousands of clients, okay? So it shows you the most interesting clients. Okay, I'll show you a demo. All right, these are live demos. We showed them in Rooted Valencia. Well, we had videos and they told us that no, that videos were not good, to do demo, that we were kind of threats, okay? That there was a threat. So we were a threat with our video, now we have live demos. No, this is not criticism, okay, to those who bring videos with them. We have done that many times before, but this time we say, okay, we'll go for live demos. So we will be using this small PC, just an ordinary one with external Wi-Fi card. So we just set it to monitor mode. We configure a channel, and then to listen to probes, we don't really mind the channel. All channels are valid for that. And then we just lift an interface. And then if we execute it with no arguments, it prioritizes all the functions. Well, you can play around with them as much as you want, where we will just write down the -i interface and then the -a for it to minimize the max. So because we don't really want to see the traffic, well, on the screen, all the max in this room, okay? So we see if it works. It shows you the configuration that you have chosen, the execution, then you enter it, and if everything goes well, notice, look, you start to see clients. Each of these lines on the left, every 2 lines, it's a client device. So here we have the MAC number, then we have the vendor for that Wi-Fi card, and then the hour when it was seen, and here, bottom right, you see the networks that are being requested. Okay, oh, Telefónica, Hotel Auditorium. So this is information that your phones are all the time requesting about. So this tool allows you in a very fast and easy manner to ask about the clients you are interested in or the MAC of the client machines. So you tell the tool to show the information of those clients you are only interested in. For instance, I don't know. For instance, if you are at a cafe and then you know that people of the company you want to attack have coffee in that cafe. So when this person walks in, you want to know that that device is being asked about. So that's what we are interested. That's what we are interested in, finding about the device of the person from the company we want to attack, okay? The person who goes and have coffee in the same cafe. So this is a very easy to use tool. It is not complicated at all. And as I say, it is available in our website. So another need that we had was when we were auditing Wi-Fi. We really needed to find the best geographical location or geographical point where you have the best signal. So for instance, if you are running a point of access, you want to do that with a point of access. Well, there are tools to allow you to do that, sometimes mobile apps that tell you about the best access points, but we wanted to have that in our terminal. So that as you are doing, for instance, remote control on, for instance, 3G, and if the signal is very close or far away to you, that's why we wanted to have it in the terminal, but we also wanted to have a feedback, like auditory feedback. You are there with your rucksack, with your camouflaged system. This is the one that you are using to see which is the best exit point. And then you are walking the street and you hear beep, beep. Okay, you are wearing earphones. This is very discreet. As I say, it was very important for us. No one should know what we were doing. It is kind of like, if you come close to it, then kind of beeps. If you move away, it doesn't beep. Okay, so earphones, we were using them all the time. Okay, we were just playing it loud, but as I say, we were using earphones. So I will just set my mobile phone to AP mode, and then David will execute the tool. Okay, we run the tool now. LK Wi-Fi. Okay, LK stands for our name. Okay. Okay, we import the channel and then an environment variable. Okay. I will lift the interface again. It is a Python tool. If you execute it in command, it gives you the different options. You say -i, then interface, WLAN 1, and then you tell it about the MAC that you want to search, and then you enter and see if it works. These messages of warning and error, this is, well, you always get them from the Python, from the library. Well, if you want to give us a patch to, or develop a patch to remove them, we will be always be welcome. Okay, can you hear that? Okay. Let's do this now. So this tool is not complicated, okay, at all, and it is very, very useful to find out about the best location, the best access point. This was a great help. Next tool. Well, we needed to use a fake entry access point. So host AP, which is the one that we used, had many features, but it didn't have any that was of interest to us. Because we want to say, I want to service the clients of this vendor, whether it is manufactured by Samsung, Intel, but do not give service to the rest of the vendors, or the other way around, because there are some attacks that, depending on what you do to your mobile phone, if you present them with a fake certificate of radios, some devices warn the users, but others do not. Okay, they are better players than us. So we wanted to say, okay, if they give you like OPAP certificate, we are not going to attack that, because it was essential that we weren't caught. Okay, no one should know that we were doing that. And how did we do it? Well, we changed the code, we made some modifications, we add some functionality variables, and you wanted to tell him by default to accept or to reject it, and then you just include the list of vendors that you want to receive the service. Okay, so we'll show you right now. Okay, we will run it with a script. So this is the vendor deny file. We don't want it to give service to Apple, and the configuration file that we will use is this one. We say vendor ACL0 as accept by default, but deny this vendor. Okay, accept them all, but the ones that say Apple in the file, do not accept them, deny them. Okay, we start that up, and then we give it the configuration file. Okay, startup hotspot, and then the configuration file. That's it. Well, it starts up other things that are we don't want, but at the end the host APT is started. Then I will tell this device, which is an iPhone 4, an old one, I'm ready. Well, if you want to give me an iPhone 6, I'm very happy. Okay, I activate Wi-Fi, looks for the networks that are known, and I don't know whether you can read it, but here it says ignore authentication request. Oh, I forgot to hide the MAC. Oh no, we have it here. Well, it is a bit anonymous, okay, and well, that's about it. So this allowed us to decide per vendor the mobile devices that we wanted to attack through the fake access point, the ones that we didn't want to attack. So the code is a patch, okay? So you download the source code of host APD, then you apply the patch to it, and then you add this functionality to it. So we are telling you about all this like very quickly because there are many tools that we developed. Okay, we don't have time for that. So when you do like complete or an exhaustive auditing of a system and the starting point is 0, the amount of information that you have to handle is very large. For if you do a capture in Kirchner, well, you end up knowing as much as you want to know or need to know. So you want to know about the access points, encryption that is used, but also the relationship between clients and access points. And that information, we can get it directly, but looking for it in the traces, but this is not viable. So the tool that you saw before, that weekly tattoo, if you are at the cafe, this is the one that you use, but you have to be there. You have to be on the spot. But we wanted something more systematic. We wanted to deploy a number of probes, and then from the information that we get out of those probes, we wanted to process that information just to answer questions such as those that appear on the screen. Therefore, we will show you a demo again. Before the demo, let me tell you how this tool works. It is very simple. You do a Kismet capture. You do a Kismet server with nearly no parameters. You know that Kismet generates XML to treat information, ready treats information, segments information, does segmentation of the networks, which clients use which network, and then our Python script creates a relational database, may do that incrementally. So you may get a capture and generates a database, and then the next one, when you get another capture, okay, then it adds data to the database. So this is the design of the database. It is a relational database, and it uses the Wi-Fi concepts that Kismet uses, okay? This is for your reference. We use the same terminal that David is using, but this time we will use another directory. Database is here. I will upload the variables. This database is generated through captures that we've been taking around here. We've been captured data or traffic these days. Well, someone asked us what we were doing with our rucksack. All right, the first thing that we will be doing is just to take out the statistical information from that database. Okay, I should not forget the -A option. So if you manage to do that without typing in the -A option, please let me know. And then these are the ESSID with the statistics, the number of clients that are done or receive probes, etc. And this is a network that we are interested. Has quite a lot of traffic. We have detected 86 APs. So I'm interested in this network, and why am I interested in it? It is a network that, first of all, we have access to. So everyone connected to that network, well, we could do something with them, with all those connected to that network, or we are also interested in it because we can replace it, okay? And if we replace it or we just break into it, okay, we just transfer the database in an anonymous form, and then it tells us about the max of the access points, so that information can be customized. So you get this information, but you can get any other information as well. APs are interesting, but we are more interested in the clients. And now we have to give it the ESSID so that it gives us the ESSIDs of this network. I mean, those related to this network, either because they have been connected before, because request tests were made, or for some reason, well, they have been related to the ESSID. These are the clients, anonymized, that are related to this network. But this is not the network that I want to audit, that I want to compromise. Imagine that I want to compromise this network. Do RAM, which is a network that we all know, which is a student's network. Imagine that I want to compromise it. I want to know that the clients that are connected to that network, I want to see which ones have that are related to that network. I will take the same query, this very same query, and in a variable I will build this. I will write down client list, and I will just remove the anonymity, and then I will do something for it just to give me the information that I want. This is field 2. This is the field that you get in the Mac, and then I may do some -u. -u. Okay, yes, so that it gives me only the information that I want. This is the list of clients. What I'm going to do now. Another command, which is lk Wi-Fi. Okay, so I'll write that command there. Okay, database, we always want to transfer it. It is the one that we use it, okay, that we are using in anonymous manner. And then I give it the clients, and then it tells me who of those clients are connected to that network. Okay, there is no problem in here. There is just this client, well, it's full of dashes, and I haven't filtered it. Okay, give me a sec. Oh yes, it is -c. Sorry for that. Okay, thank you. So we have this client. Okay, we see the networks he is connected to and why. So we are interested in the roam. I say, oh yes, well, okay, one client, two client. So if we want to have the full list, we just write down grep edu roam. Well, there are a few of them, okay, and you get them all on the screen. This is the end of the demo. We obtained information, intelligence information. Perhaps we've been a bit arrogant or too ambitious, but it is about extracting information for a Kismet capture, and then, well, to later on deploy other attack techniques.
Un comentario sobre esto.
One single comment regarding intelligence information. If you have 70 access points, as you've seen, there are so many clients in a very small environment. If you are giving around one or several buildings during several days collecting traffic, these are thousands of points of access for clients you end up having at the end of the day. So it was an unmanageable database. So one other problem to be solved was, as you can see on screen, if you go to a cafeteria, you sit around with your PC, you got my PC on this cafeteria, you don't pay too much attention. So if you built up this external antenna, nobody pay attention to you. But in some cases, we needed this to be close to the building for us not to be there pushing into, keying in on the computer. So somebody would have noticed something was wrong there. So that's why we needed a probe, a remotely controllable Wi-Fi probe without giving attention, without making that notice. So you can be on the bench for some time. But if you spend 8 hours on that bench doing the strange things, the guardian, the security guy will tell you something is wrong. This is the man in disguise as Paco on screen. But if you see a funny, strange dressed person, you need to mimetize with the environment to pretend not to be anybody aggressive. So that's why we consider certain things. The very first thing we decided to use as a probe are small PCs. So this was not it wasn't a mock-up minimum thing with a simple Linux with no strange compilations. We could manage, and we connected to it. We created a 3G modem to the PCs, both to the probe and the PC, so we got a lot of mobility all around this traffic. We put in VPN to generate secure traffic in between. It's the same. One to the 3G modems. Sometimes 3G connection drops, so we created a monitor doing the whole thing, so keep the 3G connection all the time activated. So when you get the probe ready, you have a certain scope radar of attacking. So you can transmit, you can convey from certain distance. The scope of this probe, the bigger the scope is, the more efficient the probe is. So to amplify, to widen the scope of this probe, you connect an amplifier receiving and catching signals, and you put a directive antenna to talk with antenna pointing at that part of this direction. And so let's imagine a directive antenna this big, so it would be very, very noticeable. So by looking, we got a set of equipments that were feasible for us. This is a battery feeding the amplifier, and this, you can see downstairs, is a square directive antenna, 2 inches big, and we got a very, very, very powerful probe. Another problem was to conceal this probe. What's going on? The security guy, can you please keep this? Can you grab it for me? Can you have a look at this backpack? To get the right camouflage of the probe, we used on mochila. We used a mochila, a backpack, a portable rucksack. In this environment, this fits in properly, as you can see on screen. In a travel bag, you can put even 2 antennas. You're sitting on a bench, you put your bag on your side, nobody will pay attention to you. So NTC coating lining bag, this way people don't feel frightened, and there's not even a guy keying things in the machine. We could be there and the other guy is sitting at the cafeteria or at home doing these bad things, these mischievous things. If you can park your car close to the target place, you can put as many equipment as you want. You can even put the battery on the car. So there are some places where they don't allow you to park due to several security buildings measures. They don't allow you to park. They are so paranoid all around. When you find this kind of things, you need to find other alternatives. After a lot of thinking about, we found this alternative. Let's see who is the good-looking guy who says to me, what motorcycle has in its trunk something attacking you? David called me at home. Jose, I'm gonna ask you to buy a motorbike. The company is offering this. My goodness, are you crazy, man? No, I am. And I finally took into it, but we didn't end up buying it. But okay, in the very end, he got it. This is a real backpack for this testing. We got this bag and a small bag as well. In this bag, or in this suitcase, in this little suitcase, we got 2 systems. Can you see this on screen? Approximately. This is what it looks like. It's a customized bag or suitcase. This suitcase, when you park your car in the sun and it's not winter, there the temperature it reaches inside. Okay, ventilation problems. We could put a fan or a ventilator inside. So in the very end, we drill in some holes downstairs at the back. Now it's covered with the trader and the brand name, user's name. And there you go. This is what it looks like inside. The 2 white things, what you see on screen is a directive antenna, square size. Now Jose is moving it, mounted on a robotized mechanism. I will comment on it. Inside this bag or this suitcase, you can see a GPS. Should they steal the motorbike from us? I'm not joking. When one of them was displaying the probe and you park your motorbike, the other guy, one of us, was checking from a very, very discreet place how you're moving around in a very, very tasteful way. And we checked that the motorbike was not stolen from us. This is the amplifier. And over here, we got another similar unit. This is a mode in 3G. A modem in 3G. This modem allows us to connect. This sparkling light thing is a servos controller. Those who attended the lab have noticed to control the robotic servos. We use this, and these things over here, these elements, are for muffle the bumpy rides. This was a breaking thing for our heads because the suitcase over here, but you cannot go there with this riding in a very, very, very easy way. This was a bumpy ride for us. We had to devise and design protection measures. As you can see on screen, the most protective one was to go to a low-cost shop. Please, do you have beaches cylinders? We cut them off, manipulated, and this is this. Are you going to the beach? Are you going to the beach? The Chinese man told me. This is the support, the chassis. You can see 2 batteries touching on horizontal, and underneath the PC is dangling or hanging. It's a small PC which is started out since 8 a.m. It's scoping with the whole thing. And we can see the PC on the other side. This is a system we mounted and set up. Autonomy was a must for us, and the usage of these batteries allows us to park these at 8 a.m. and until 8 p.m. No problem, guys. But somebody can tell you there is a PC consuming and using up the energy, but the moment you shut down the screen, okay, batteries kept doing their job.
Bueno, esa es la sonda. Sí, perdón.
This is the probe. This is the appearance, the look-alike industry. This is him. This is not me. This is him, and this is the small suitcase. The suitcase, you can see it. Okay, this is this big. No, but when you see a park surrounded by another 8 motorbikes around, this is not noticeable. Nobody pays attention to it. Originally, this bag was the version 3.4. The antennas were orientable in a manual way. When we parked close to our target, there was one. It was very interesting for us, but we didn't catch it properly. So let's imagine the bag over there. We were using the headphones to communicate ourselves in between. Now it's doing better. It's doing worse. So, and what's all around now here? How are you doing at this moment? Is it better? Is the antenna signaling better? Was it now? We soon realized this was not a good idea, so let's robotize the antenna and let's continue to be discreet people. Let's avoid this kind of things you can see on screen. We cannot allow to have this situation. We cannot allow to have through this situation. We cannot allow suffering this situation. A guy manipulating a bag in front of where the guardian is custodying the door. Let's robotize the whole thing. So we got some requirements to be able to connect through 3G in a silent way, very easy to reconfigure, and allowing us the possibility to reorient the antenna properly. All of the people who were in the laboratory doing this software are familiar with this. We created software with a library which allowed us to calibrate the servos, configure them, and put it in a JSON. And from now on, you can enjoy the El Capim, the utility which tells us put yourself on this position. This is the PAM movement. PAM things stands for panoramic, and TIL is this movement. With these 2 degrees of liberty, we move around. Very firstly, we're going to connect the PC, and we didn't connect the 3G connection due to the fact that it's very unstable. Please, can I have your mobile phone?
Bueno, parece que hay suerte. Ahí sigue esto como...
We're lucky. This PC is over there since it's very morning. Very first, let's move it. If not, we'll take out the camera again. More or less we can see it. We're gonna show you the command, station 1, you're telling move to a neuter 1990 position. It's badly calibrated. We're sorry, this is not 1990. It should be calibrated properly, but I didn't do it. If you pay attention, it goes very slowly. Why? Because of the noise. You're right. So we can make it as quicker as possible. When we got it back at that time, it was slow. I will tell you an anecdote. Someday we were testing it, and we were not very reliable on this system. We didn't rely on the system. There's so much noise in the street. You're paranoid. Was it? How is it doing? The servo, when you configure it badly, starts turning around, spinning brutally, and we found a crowd of people around the motorbike smoking. They don't hear it. So since then on, we trusted it. We trusted the system much more.
Voy a moverlo un par de veces para que veáis que...
I'm gonna move it a pair of times. 2020, quicker, you can see how it's moving quicker. Now, 160 pound, 40 is the tilt. But this was used this way. We took the little tool as before. I'm gonna take out another terminal. The Wi-Fi finder, this tool, I took it. I'm gonna load the smarts. I'm gonna configure the card plate on monitor mode. I could have done this before. Channel 1 configure. I'm gonna orientate the antenna towards Cranket, towards this place, the coordinates you can see on screen. I'm going to try you guys to see it all at the same time. Okie dokie. So I now launch the Wi-Fi finder with the interface 3 -M Mac. Let's see if I grab it. My mobile is on. Okay, it's over here.
Vale, pues lo pilla, no lo...
Okie dokie. It got it. It caught it. This is very low emission sound. So you can see the signaling. How did we use it? By moving the antenna. Let's see where we can hear better. I'll put myself as access point. This is a access point as if it were in a building. Can you see it? Can you see that I'm moving and moving? Everybody's seeing it properly. Here we go. Now he's pointing over there. I'm going on the other side. This is a blind test. Instead of 90 pound, I will write in 100. I'll write 1,200. My tool says no. Now I will keep still. You do. This is a blind test. Blindly? Is it blind? 80, 40. It seems it's going slightly up. It's going slightly up. What it seems. This was set. Let's put it a little bit back. 90. Let's see if we can get it this way.
Uy, me estoy yendo para el otro lado, esperad.
I'm moving to the other side. Here is a bit better. Now I'm going a little further down. A little bit further down. This was it. We use it this way. I would say this is the right position. Should I try with the ampli, David? 4950 is okay for me. I never tried it before in a small field, in a closed area. There are some reflexes or reflections, I don't know. If it's not working properly, we'll do it with ampli. We noticed that this manually down thing this, which is done manually, can be also done automatically. In the very end, you want to have a button and say, okay, go. And this is moving, and is doing the right things to self-orientation, to find the right point where you can get and receive the signal. Let's see if this is working. This is a freaking demo. I never tried this before. I will stop it. I don't need it. Let's see if this works. I'm gonna tell it. Please find the most right or the rightest place for you to be on the network. One second. Let's put on the webcam. It's over there. Now speed it up. Use station 1 as interface UVLAN 3. You should have a limit in the pan, otherwise it go seen behind backwards. I'm gonna write 30 and 140 and a T limit between 10 and 90. This way, I'm okay with it. I will tell Mike I'm looking for OXL. It's now moving and it's measuring. It's measuring when it's finding a maximum value and it takes note of it. Option -B. Okay, it's moving and it's finding the maximum. When it finds a maximum, instead of saying this is the maximum, it makes sure it reduces the space of searching, and the next time it finds it, reduce the space of finding until there's no room or space to find. Sometimes there are some ties or draws. The sensitiveness is such when there is a tie, it measures the gains on the points to get a tiebreaker. There is a limit of ties, so this is it. We could have implemented in a different way. Now a maximum things for a different direction will take us longer because it's the time allocated to measure. It changed the center to this point because it's not the right one. It starts measuring one more time in order for it to see if it can find it. It's moving on the other side. In a closed environment like as this one, the thing is that we're having reflexes moving from one place to the other. If it's getting more signaling from another place, this virtuate what is going on here. Reflections in an open space would have been a problem for us. If you pay attention, the antenna is moving very, very, very lightly because the moment it catches the maximum, it starts stopping. It focuses on that, and corrections are minimum. Everything can be set up. You can set up when it jumps, when it's skipping, how long you want to measure. Everything is configurable. In the meantime, I will show you where he is pointing at. Where is David? It's not bad at all. If we test it with the ampli, it would be better. I think it makes no sense to test it again. The idea is on that position the antenna is catching a signal considered to be the right one. Okie dokie, so far so good. I won't do anything else.
Ahora está gestionando un empate.
Cut, this is a tiebreaker. Is it a tiebreaker now? The P is moving. To wrap up, this is the last demo we got left for you guys. Our conclusions to all of this. Generally speaking, we should be getting this mistake because of the fact of something is published or it does not exist. If it exists, we have to act if something is existing within every scope of security. If you can do something, even though it takes a lot of manual effort, you have to consider that it exists, that it's there, and you have to protect against it. For us, Wi-Fi attacks and wireless technologies, we have to protect them within the organization. This is our main recommendation. Without going into the building, without knowing anybody, that can be an access point. Other thing we have noticed that some organizations have the concept mistake that by limiting the scope radius of reaching, this is enough. I have to limit the scope radius of reach, especially considering the wireless infrastructures to make the whole thing secure. You got some references and some links on screen. Should you have any questions, please raise your hands and ask. Thank you.
Hola.
Hello, several questions. Very quick round of questions. First question: can we adapt a rocket launcher to it? We don't know the specifications of rocket launchers. Depends on its weight. This can take 50 grams or 1 kilo of weight. The servers we have used are small, only to take on this weight, but we can control it with a webcam and with any other thing whose weight is like a special rifle. Second question: can this track down a client instead of an IP? We thought about this thing about persecuting or tracking down a client, because when a client is not connected to a network, is emitting with less frequency. It emits pros and requests every little time. It's difficult to trace that person or this client down. There are some clients in movement. So how can I trace down a client who is moving? I'm gonna switch off the antenna. We can do the search with an antenna, and let's see where it's moving this around. It's a bit complicated. This can be done with the robotized system, with the backpack system. You can use the commonly known technique as hello, cute, and you get closer to that target and you say hello. If this is the person to be concerned about having a mobile, you can only have to spend a while around it, and you'll see activity from this machine, and you can confirm that's our target, that's our person for this specific kind of situation. A very simple question. Can you go back one slide in your presentation? I would like to focus with the links you mentioned before. That's one. You go so quickly through this. I didn't notice this. There we go. It will be uploaded on our website. But sorry for skipping this quick. Have you ever contemplated to use a rush of replay, or are there many problems running the RAM to control servos? Not for everything. Instead of having a laptop and having this big thing, I have something similar, and it is 10 times smaller. You're right. You can reduce it a lot. This fitted our motorbike, and that's why we say, okay, go for it. It was this easy. Our decision was this easy, but you can do it with a spell reply. You can put it in your pocket. We consider, regarding the servos, that there are certain little machines you connected to the servo port with a command and directed to specific places. It's simple this way. Question over there.
Ahora. Vale.
Hello. My question, have you ever raised a host API with EduROM? Or should you be yours changing the DUROM password? Should it be yours? Have you ever been detected? So the tenet does not apply here. It should not be yours. Oh, you know that the password has been changed. The blame is not on us. Good person by saying this. I trust you. We weren't those who. We only did passive capture to show you examples of networks in our database, but it's always passive capture. We didn't attack anybody under no circumstances. We are legal people. Over here, I got a question for you guys. Have you ever thought, I guess that you bore in mind that okay, the police can be chasing us. If the police detect you have this arsenal, this machine mounted in the trunk of your motorbike, what's going on? We thought how to improvise our excuses to the police. How can you explain a police agent? Please open the bag, open the suitcase, and the agent may see that. What excuse could have made to this police agent? We didn't know. In fact, it's too hot, and the police agent put a traffic fine against us. The police find it because, of course, this motorbike is buzzing, is horning, is really. What do you have in your backpack? I have a laptop. Period. So I will fine you because you walk and ride on the pavement, on the sidewalk. So continue. I'm only interested in fining you. The police officer says the perfect thing about the bag. Okay, my gosh. When they stop you with the bag, then they ask you to open the suitcase. What is all around? Oh, I don't know what is in my backpack. Servos is absolutely unbelievable. I got something regarding the tracking down of clients. Can we force the pro request emission from the client by raising or lifting the AP request every second, forcing the client in their number of the connections and making a more fluid tracking? We don't know how to do it. We considered it, but we didn't search on it. So if we cannot do it, it would be very interesting to do the client part. We don't know if this room somebody can answer your question, but in principle, we don't know the answer. Can you remind the radio frequency bumps? If you are moving around the area, you want to destroy and crash. You want to localize somebody, you put access points and you create a grid at position. That would be a solution. This could have been done. It was not our main necessity, but it was a solution to locate and track down somebody. The moment you get a measure, you get a data. It's not like here you have to measure constantly. There's one over there. Congratulations, wonderful presentation. Once you have laid the access points, you can discriminate mobile phones based upon the Wi-Fi car or the manufacturer. Can you discriminate depending on other values such as the software release version? As is implemented now, it only check that from the Mac on the Wi-Fi card. The very first 3 bytes are checked. It's a white chart translated file, and we assume this is the question. This can be extended to a more finer detection of why somebody is doing this, but we didn't check it. Perhaps you can categorize and to to take the signature from different mechanisms and to create a signature about when is device or other. There's a question over there at the back. We are running out of time. Thank you guys for your nice presentation.